Let's go and take a look at these two examples in SQL+. I'm going to copy and paste this one. I'm going to calculate the standard deviation on the standard price column in the seating map table. And I come up with this number. The standard deviation is 35.4923851. This is the standard deviation of each value from the mean. A mean is an average. Now let's go a little further with that standard deviation and break it up into groups. So what I'm going to do is I'm going to calculate the standard deviation for each venue across the seating map table. So last time we found a single row. This time we actually find 3 rows. So we've got 3 venues in the seating map table. Lots of records probably. If we count the rows, we find we have 693 rows. We should find that if we read all the data, which we won't do because it's a lot of records, we'll find that we have a large number of rows for each venue, and this will take the standard deviation of the price, the average distance from the mean, for each venue. There is one interesting thing to note here. Note that selecting and grouping by the venue ID has sorted the data based on the venue ID. We can prove this in 2 ways. Obviously, the first way would be to retrieve all the data from the seating map table, which I suppose we could do. If we look at the data here, as you can see, the 5s came before the 107s, and they also came after the 33s. What I'll do is I'll go and run that group by again. See, it's sorted based on the venue, based on the group by column. Why is that? Because group by will sort. As we saw, these values were not sorted. This is the physical order up here, the query on the whole table. In other words, the physical order in which the data was inserted. So what I'm trying to show you here is that group by will actually sort the data. It does do an ordering function. That's important to remember that. So, we have aggregate and analytical functions. We have a gray area between the 2 types of functions, because some functions can perform as aggregations and some can perform as analytics. Here's a very simple summary function. I'm selecting the count of all rows from the category table. And here's the count from the category table. 34 records. So the count function is an example of a summary function, a simple aggregate function. Statistics functions. Statistics functions form part of that gray area between aggregate and analytical functions. Statistics functions can really be aggregates or analytical type functions. Here are my 2 standard deviation examples again. I like to break statistics functions up into 2 categories: calculators and distribution functions. The cumulative distribution function is a function which is used to produce information that can be used to draw histograms, for instance, distributions of data. The ranking function can be viewed more as an analytical function. However, in its simplest form, it's not really either an aggregate or an analytical function, since it can really be used to retrieve a single value. What the rank function does is pick the rank of a value amongst a large number of values. So it says, what rank is the value 10 in this table? The result is first. We won't worry about running that function for now. Grouping analytical functions. Grouping analytical functions are applied within rollup and cube clauses. Here is a simple example of an analytical function.